Today we're going to be learning about phase changes. This is a phase change diagram with different states of matter of water. And I want you to remember that phase changes are going to be physical changes because they're reversible. So phase changes are physical changes because they are reversible. During this PowerPoint, I'd like you to take notes on your notes that you picked up on the way in, and I'll let you know what kind of notes to do. We're going to start with filling in the blanks. So there are different types of phase changes, including melting, freezing, boiling, which is also known as vaporization, condensation, and this one is most likely a new one, sublimation. And we'll see a short video clip on this. Melting point is the temperature at which a solid changes to a liquid. So it's the actual temperature at which a solid changes to a liquid. And you're writing this down on your note template. The freezing point is the temperature at which a liquid changes to a solid. So it's the temperature at which a liquid changes to a solid and starts to begin to freeze. Vaporization or boiling is when the change occurs from a liquid to a gas. Boiling point is the temperature where this happens. So vaporization or boiling is when it changes from a liquid to a gas, and the boiling point is the temperature where this happens. Condensation occurs when a gas is changed to a liquid. One example, like the picture shows, is when you have a cold glass of water or Pepsi and water droplets form on the outside of the glass. This occurs because of the water vapor in the air becomes cold and turns into a liquid on the outside of the glass. Another example of this that we talked about last week is when you take a hot shower and the water vapor from the room condenses or turns back into a liquid on the mirror or the window in the room. The last example is when you step outside and the grass feels wet or dew. This is an example of condensation as well. The last phase change is sublimation. It's when surface particles of a solid escape directly into the gas phase. So when a solid turns directly into a gas. This occurs when they do not go through the liquid phase. An example of this would be dry ice, like you see on Halloween with the fog. In 1 second, we're going to go ahead and look at a video clip of dry ice. We are now going to watch a short video clip of a teacher with a piece of dry ice.
Anyway, you'll notice that here this piece of dry ice does slide around fairly easily. Once it has that smooth bottom, it ends up that this kind of acts like a puck on an air hockey table. The gas that's coming off the bottom as it sublimes, as it goes straight from solid to gas phase, kind of acts as an air cushion, then it allows it to just kind of slide around. This is fairly low friction here, a nearly friction-free surface, although there is certainly still air resistance, and that's something we'll talk a lot about later in the year when we do chemistry. Now, we've already mentioned that the dry ice itself is white. What about the solid dry ice is white? What about the gas phase of carbon dioxide? Because that's all dry ice is, the solid carbon dioxide. What about the gas phase? What's it look like? Aha! Trick. What you're actually seeing is water vapor. So, carbon dioxide is actually clear. Everyone exhale real quick. Can you see your breath? No, of course not.
As you could see in the video, the piece of dry ice, which was a solid piece of carbon dioxide, was subliming directly from a solid into a gas without going through the liquid phase. The next thing that we're going to do is look at an actual phase change diagram. During this time, I would like you to fill out the phase changes and the melting point and boiling point that you see on the phase change diagram on your own handout. As you can see in the phase change diagram, on the bottom there is energy, and on the y-axis on the left side there is temperature. So the first phase in a phase change diagram will always be a solid. The reason why is because solid particles move the slowest, so they have the least amount of energy, and they are usually the coldest because they have the lowest temperature. This makes sense because yesterday we learned that the solid particles move slowly or vibrate slowly in place. As a solid starts to become hotter, the melting point occurs, so the temperature at which a solid starts to turn into a liquid. So in this phase change diagram, the melting point is at about 0 degrees Celsius. At this point, the solid begins to turn into the liquid. And the liquid is over here, which as you can see has higher energy and higher temperature than the solid. At the melting point, it's just the beginning of this phase change. At this point in the center, there is both solid particles and liquid particles as it goes through melting. You'll also notice that during melting, the temperature stays constant or the same. During the entire melting phase for this substance, it is at 0 degrees Celsius. Next, after the liquid phase, we get to the boiling point when the energy and the temperature get high enough. At this point, the liquid starts to turn into a gas, and our gas is located all the way over here on the right side of our diagram. In the middle here, we have boiling or vaporization. This occurs in this substance at about 100 degrees Celsius. Different substances have different melting points and different boiling points. Just like we saw before with melting, at boiling, there's also liquid and gas present. When it turns into the full gas, you see the line just become red over here. So make sure that you have each of these points labeled on your own diagram. Next, using your diagram from today and your notes, I'd like you to fill in this chart of phase changes. This column over here says starts as. The next column says ends as. And the last column says hotter or colder. I'd like you to go from each phase and identify what it starts at, what it ends at, and if that phase becomes hotter or colder during the change. So for example, melting starts as a solid and turns into a liquid. If it's going from a solid to a liquid and it's melting, is it becoming hotter or colder? You're right, it's becoming hotter. I'd like you to do this for the rest of the phase change diagram. If you need to, you can pause the video here while you fill out the chart. After filling out that chart or the diagram, I'd like you to move on to the last part of your handout, which is a phase change concept map. Using this picture here, I'd like you to fill out the phase changes, the states of matter, and any of the other information you see here. So for example, when you go from solid to gas, the arrow that goes between them should be sublimation like we saw in the video. In addition, when we go from liquid to gas, it should be evaporation. This is another word for boiling or vaporization. While you're filling this out, I'd like to remind you that phase changes are physical changes, meaning that they're reversible. For example, when a liquid goes to a gas, it is evaporation, but it can be reversed when a gas goes to a liquid through condensation. So these are reversible phase changes or physical changes. Once you are finished with the video, go ahead and work on your worksheet that you picked up on the way in as well, and then we will move into the directions for our lab.